Hello everyone, I am Noor Zainab and in this video I'm going to discuss that how you can derive the second equation of motion in an easy way. There are three equations of motion in physics. These equations relate velocity, time, acceleration, and displacement or distance. In these equations, the initial velocity can also be replaced by the letter u. So now let's consider a graph between velocity and time. If we calculate the slope of this graph, the slope of a graph means the vertical component of the graph divided by the horizontal component of the graph. In this case, the horizontal component is time t and the vertical component is velocity. So we can say that the slope of velocity time graph gives us acceleration. Whereas if we calculate the area of this same graph, what we get is displacement. In order to calculate the area of a graph, we have to multiply the horizontal component, which is time, and its vertical component, which is velocity. So the area of the velocity time graph gives us displacement, whereas the slope of velocity time graph gives us acceleration. Now let's consider a car which is moving with some initial velocity. After some time t, what happens, the velocity of the car is changed to vf, which is the final velocity of the car. If the initial velocity of the car is 0, then the velocity time graph of this car will look like this. But if the initial velocity of the car is not 0, instead if it is some value of vi, the graph will look like this. The vertical axis is representing velocity, whereas the horizontal x-axis is representing time. As the car is moving with some initial velocity vi, the graph will look like this. Here the initial velocity is not 0, and we can also see the final velocity of this car. So now in order to calculate the second equation of motion, we should know what is a trapezium. A trapezium is a quadrilateral. By quadrilateral it means that it has four sides. So a trapezium is a quadrilateral which has at least two parallel sides. Out of the four sides, only two sides are parallel to each other. These parallel sides are known as the bases of the trapezium. So if we have to calculate the area of this trapezium, you can see the formula for finding the area of a trapezium, where A is the length of one parallel side and B is the length of the other parallel side, whereas h is the height, which is the perpendicular distance between the two parallel sides. So we can say that a trapezium is a four-sided polygon or a quadrilateral with at least one pair of parallel sides. So now if we again go back to our previous graph and we do some labelings, what we get is this. We label the initial velocity as vi and the final velocity as b, and hence we get a slope ab, and the time is taken as ad. So if you focus on this graph, you can find a trapezium. If we recall the definition of a trapezium has two parallel lines. So in the graph we can see that there are two parallel lines, and we know that a trapezium has four sides. So one side is this, one side is this, and one is this, and the last one is this. So here we are getting a trapezium OABD. This is a trapezium. As we have discussed earlier, that the area of the velocity time graph gives us displacement, which is denoted by s. So by applying the same formula which is used to calculate the area of the trapezium, we will find the area of this velocity time graph. And by finding the area of this velocity time graph, we will get our second equation of motion. Area of the trapezium OABD gives us displacement s. So by writing this formula, we can say that the displacement s, which is the area of this velocity time graph, equals to the sum of the parallel sides multiplied by the distance between the parallel sides. This is the formula to calculate the area of a trapezium. Here OA and BD are parallel lines, whereas the distance between OA and BD is OD. We get this formula by placing the values of all the sides. Now after putting the values, we can see in the graph that OA in the graph shows us the initial velocity, whereas BD in the graph is giving us final velocity. Also the OD line segment shows us the time t. Hence we can replace these letters by initial velocity, final velocity and time t. So we get this equation. Now we are going to put the value of final velocity. From where we can get the value of final velocity? As we have studied in the first equation of motion, the first equation of motion gives us a value of final velocity. So by using the first equation of motion, which is the final velocity equals the initial velocity plus acceleration into time, we put the value of final velocity in the equation. So Vi plus Vi will be equal to 2 times the initial velocity. Now we can multiply this time t with both the terms, and remember that this time t is multiplied by both the terms. When it is multiplied with 2Vi, it becomes 2Vit, and when it is multiplied with At, it becomes At squared. Anything multiplied by 1 is the same number, so when this expression is multiplied by 1, we get the same expression, and it is divided by 2. So as we have two terms which are being divided by 2, we can write them separately, each of them being divided by 2. These both 2's will be cancelled with each other, and so we get this equation, which is the second equation of motion. So simply what I did was multiplied this time with both the terms and then divided this 2 with the whole expression, and I separated them and we got this second equation of motion. You have to always remember this whole equation is only possible when the acceleration is constant. This equation allows you to calculate the displacement of an object when its initial velocity, acceleration, and time are known. So now that we have discussed the derivation of the second equation of motion, now let's discuss that how this equation is converted into the free fall motion's equation. In free fall, all the objects fall with the same acceleration regardless of their mass. And this acceleration is known as the acceleration due to the gravity, and its value is always constant, and it is 9.8 meters per second squared. In free fall motion, two conditions are followed. The acceleration is always constant, its value is 9.8 meters per second, and the direction of acceleration, because acceleration is a vector quantity, the direction of acceleration is always directed downward. So in free fall motion, in order to convert this second equation of motion into the free fall equation motion, we have to replace s, which is the displacement, by height h, and acceleration is replaced by g. So we get the second equation of motion, which is for the free fall motion. So by replacing s with h, which is the height, and a with acceleration g, we are getting our free fall motion's equation. So in this video we discussed that how we can derive the second equation of motion in an easy way. If you still have any questions, you can ask in the comment section. Like, share and subscribe to my channel for more videos, and thanks for watching.